Welcome to Engineering Solutions. Today's topic is under organic chemistry. Qualitative and quantitative determination of elements present in an organic compound. When you are given an organic sample, say X, and you are asked to determine the particular element present in the organic sample, the procedure to use to be able to get the particular element present in the organic sample is what we determine as the qualitative analysis. But when you are asked to determine the amount or the quantity of those elements present in the organic sample, then we determine, or we call that one as quantitative determination of that particular sample. Qualitative analysis of an organic compound. An organic compound contains carbon and hydrogen, and sometimes oxygen, sulfur, nitrogen, and then the X group. That's chlorine, bromine, and then iodine. Let's first look at the qualitative determination of elements present in an organic compound. Carbon and hydrogen. When you are given an organic compound and you are asked to determine the carbon and hydrogen present in that particular organic compound, then you need to look for a pure oxidizing agent such as copper 2 oxide, and then pure oxygen. So we are going to heat the organic compound with a pure oxygen or a dry oxidizing agent. In the process, the carbon present in the organic compound will be oxidized to carbon dioxide, and then the hydrogen will be oxidized to water. But this needs to take place at the presence of a pure catalyst. The reaction to determine carbon and hydrogen in an organic sample. Heating the organic sample in an idiometer or reaction at an idiometer. Pure oxygen. The carbon will be oxidized to carbon dioxide. Hydrogen will be oxidized to water. Now, the effervescence of the gas. To determine whether that gas is carbon dioxide, then we need to pass the carbon dioxide here, the gas here, through lime water, calcium hydroxide. So passing the carbon dioxide through lime water, we'll change the color to milky color. That's calcium reacting with this calcium carbonate plus water. So this is the lime water. Change to the milky color. So the milky color shows that the gas evolved is carbon dioxide, hence the element present is carbon. To test for water, you need to get white anhydrous copper 2 sulfate, or what we call cobalt 2 chloride. White anhydrous copper 2 sulfate. When water is added to it, it will change to blue. While cobalt 2 chloride, which is blue in color, when reacted with water, or water is added to it, it will change to pink color. So anhydrous copper 2 sulfate, white anhydrous copper 2 sulfate, when you add water to it, to change to, this is white, this is going to change to blue color. So the water of crystallization, say X, this is blue. Okay. Or you can use blue cobalt 2 chloride. Adding water to cobalt 2 chloride will change it to pink. The water of crystallization, say X. So there is the procedure to determine carbon and hydrogen, an organic sample there. Qualitative determination of carbon and hydrogen present in organic sample. You need to get a dry oxidizing agent such as copper 2 oxide or pure oxygen. React it in an idiometer. The carbon will be oxidized to carbon dioxide, and then the hydrogen will be oxidized to water. To determine whether the gas involved is carbon dioxide, pass it through lime water. And when lime water changes to milky calcium carbonate, it means the gas there is carbon dioxide. For water, white anhydrous copper 2 sulfate changes to blue, or blue cobalt 2 chloride, which will change to pink. So that's the procedure to determine the qualitative determination of carbon and hydrogen present in an organic sample. Now, let's look at sulfur, nitrogen, and the X group. For sulfur, nitrogen, and the X group, that's the halogen, chlorine, bromine, and iodine. We have two procedures. We have number one, the Lassaigne Sodium Fusion Test. Then two, we have the specific test. So the LSFT, the Lassaigne Sodium Fusion Test. In the procedure to determine sulfur, nitrogen, and the X group, you need to get a pure sodium metal. Then you get a fusion tube like this. Here your benzene burner, say this. You drop the organic sample into the fusion tube. We are going to heat the fusion tube containing the organic sample, then drop pure sodium metal. It's added. We heat it for some time, and when it becomes red hot, then we drop the fusion tube into a china dish containing distilled water, or if you like, you can put the red hot fusion tube into a mortar, then we grind it. Then after we add distilled water, then we filter it to get your filtrate. The filtrate from the Lassaigne Sodium Fusion Test contains this. You have your sodium bonding with the carbon and nitrogen, 1. We also have your sodium bonding with sulfur, like this. So sodium plus, sorry. Then we also have sodium bonding with S groups. Okay, like that. So these are the products after the filtration, the Lassaigne Sodium Fusion Test. Now, to determine sulfur, then we come to the specific test. For specific test for sulfur, we take the number 2, the sodium, and then reacting with the sulfur, we take the number 2. Then we do specific test on the number 2. For specific test to determine the presence of sulfur, this takes place in an acidic medium. The sodium there is a spectator ion. So in an acidic medium, you add what we call nitric acid. Nitric acid so specific test for sulfur. Add nitric acid to your filtrate, a portion of the filtrate which contains your sodium and then the sulfur, the portion of the filtrate, to determine sulfur present in your organic compound. After the Lassaigne Sodium Fusion Test, take a portion, then you add nitric acid, HNO3, or ethanoic acid. Then you add a portion of lead acetate or lead nitrate into the mixture. Then in the process, you have sodium in the process, the addition of the lead nitrate to it will make the lead bond with, react with the sulfur to form sulfide, this, which will give us a very deep color black PPT. So the presence of the black PPT after the addition of the lead nitrate or the lead acetate to it will show a black PPT, which shows the presence of sulfur present in organic sample. Or if you don't have ethanoic acid or your lead acetate to determine the presence of sulfur, then you can add sodium nitroprusside, which okay, so sodium nitroprusside will be added. Get your NO like this. Okay, so addition of freshly prepared sodium nitroprusside to the mixture, your filtrate, will make the sulfur bond with the sodium nitroprusside. So have the sulfur bonding with your sodium nitroprusside. This sodium nitroprusside is a compound normally used to prevent bleeding during surgical operations, and also a drug used to prevent high blood pressure, to lower high blood pressure, sodium nitroprusside. So the reaction now will take us to plus NO. Okay, and this will give us a purple color, showing the presence of sulfur in the organic compound. So that's a specific test for sulfur. Now let's look at the specific test for nitrogen. For specific test for nitrogen, that takes place in a basic medium. So you can add sodium hydroxide to the filtrate. Then after addition of sodium hydroxide to the filtrate, then you add iron sulfate. The addition of the iron sulfate will dissociate, and the iron is now going to react. The iron sulfate will now dissociate, and the iron will react with the OH group. This reaction can tamper with the specific test for your nitrogen. Hence, you need to apply heat to it, so that any gas present in the filtrate, you eliminate any gas present in the filtrate, so that it will not hinder your final specific test for nitrogen. Then after, we will add iron chloride. The addition of iron chloride, iron 2 chloride to the mixture will now make the iron bond with your nitrogen. So let's look at the reaction for the specific test for nitrogen.